Hello, by names of Blessing Agaba, and I'm here to present an idea about my project called Fashion Assistant. By the end of this video, you will know more about it and you'll actually get to understand it better. So, what is Fashion Assistant and how will it actually help you? It will help you to make choices of appropriate clothes for different social gatherings. We have parties, we have meetings, we have school, rather than being underdressed or overdressed or inappropriate or indecent, and which will make you under, of course, even choosing these clothes itself wastes a lot of time. So it will save you a lot of time. It will really save you time, and it will help you choose clothes according to trend, decency, matching outfits, colors, depending on what's in your closet. Or if you want to actually purchase, it will help you not waste money. It will help you save income from buying unnecessary stuff, but actually buying the appropriate stuff. So how will artificial intelligence apply to my this small project? The system will receive data about the kind of social gathering you want to attend, the crowd, the appropriate options. This will be through audio and text. This will be through supervised and unsupervised learning techniques that we can actually get the data. You know, AI is actually supposed to be data driven. We'll get the data from models, fashion brands, people around the community, images, from depending on what these people normally wear, and the system will keep adjusting depending on your opinion, comfortability, religion, and preferences. And let me first adjust this. In addition, of course, to weather, what type of data will I be using? I'm going to be using images where I'll be taking pictures of the most preferable and appropriate dressing culture. And of course, for the side of the system, it will display the options for the user to pick from. We have the sound and the text. This will be through you either writing text in the system, asking for any kind of clothes that you want for any gathering, and the system replying you back either through text or sound. We have the numeric, which I believe is about numbers. The system will be able to determine the user's height and size, which are numbers, for the appropriate clothes. And of course, the weather, which I believe can also be determined numerically using numbers. And this is, we have the differences between supervised and unsupervised learning. I have to clarify more on those. Supervised learning deals with labeled data, while supervised learning deals with unlabeled data. Supervised learning, you don't actually have to put data labels, like give it instructions. Sorry, that's unsupervised. You don't have to give it instructions. The system will work on its own. While supervised learning deals with labeled data, you have to give it instructions. With supervised learning, you have to feed knowledge into the system so that it can actually predict future instances. But with unsupervised, the model works on its own to discover things that are not visible to the human eye. You don't have to feed any data into the system. Supervised learning has more tests and models. The fact that you have to feed data into the system, you have to test it, you have to make as many models as you can so that it's perfect. But unsupervised learning has fewer tests and models and this controllable environment, of course. Then we have two supervised learning techniques that I'll use in my project, and that is classification and regression. And how will I use classification? I'll take different images of the most appropriate to dress people and feed them into my system. And classification actually involves uh, uh, grouping classes that are different together and actually separating them. For example, for my system, I have the female class and the male class, where the type of clothes that the system will share for them will have to be different because they're in different classes. Then regression, I'll consult from the different fashion brands so that they'll give me suggestions when a user asks for a specific brand. Assuming there is Chanel, Coco Chanel, and a brand, they'll be grouped in their own clusters, in different clusters. There's a Coco Chanel cluster and the A brands cluster, and this will actually depend on the number. If a specific user comes to the system and asks for a cloth that they want, the system will determine how many number of times has this user actually asked for this brand, and it will actually, if someone's like a swimming attire, they will be given like a Coco Chanel brand just simply because they've asked for this brand more times than the brand's brand. That's how regression works. We have unsupervised learning techniques and how they, of course, help in my project. Me to use association and clustering. So clustering is an unsupervised test that is used to find important relationships between data points. The system will be able to adjust, replicate data about the users, culture, age, cost of living, and show the matching codes depending on that. Like giving an example, if your culture is a Muganda, definitely the system has to know you will, if you're going for, let me say, a traditional gathering, you will definitely have to ask for Agomesi. If you're a Minyankole, you definitely have to ask for Moshanana. Then clustering is an unsupervised task which involves grouping the similar data points. And how will my system use this clustering bit of it? Official wear will have, the system will be able to adjust and adapt to the habitual schedule and provide regular options for the clothes. For example, weekdays, if a specific user, weekdays they do official wear, and weekends they do gym wear, church wear. Official wear will be in its own cluster, gym wear will be in its own cluster, and on a specific day like Saturday where the user has to go to gym, the user actually doesn't have to waste time telling the system what they want. Besides, actually, there's no need to feed. We are talking about unsupervised learning, so actually, there's no need to feed data into the system. The system already knows today is a Saturday, it's gymwear, so it will use that cluster of gymwear to provide clothes for that day. So of course, these are the technical challenges. First, there was scarcity of data, which resulted into inaccuracy, or it reduced actually the accuracy, and this led to incompetency. How did I solve that? I had to increase the variability of the data that I used by searching for as much data as possible. And then, as less computing power, there was really large data and resources that were required. So my computer had to slow down. The computing power was really less. And how did I solve this? I had to use high-speed computer to solve the problem of this less computing power. Then there was data privacy and security. To explain this is where people can actually gain access to your data, which is really not secure. And how did I solve this? It was through testing and ensuring that my system is secure and there is privacy. For example, I used enterprise cloud solutions. So there is accuracy, recall, precision, F1 score, and these are the differences. Accuracy, this is an evaluation metric and is the fraction of predictions that the model gets right from the overall number of cases. So accuracy, it determines the true positives and the true negatives. That is it, the fraction of the true positives and the true negatives. Precision actually works with only the positives, and it considers the number of positives you get wrong, and it's defined as it quantifies the proportion of the correct number of positive class predictions that actually belong to the positive. Recall also consider the positives, but this time it chooses only out of the truth that you were able, that the system was able to get, how many were actually right. And of course, F1 score combines all the above. It's the recall, it combines the recall and the precision, and of course the appropriate artificial intelligence evaluation metrics that actually worked for my project. I have the confusion matrix, and it is a table that is used to define and visualize the performance of a classification algorithm, also known as an error matrix. For this project, the system may predict a right cloth or wrong based on the classification algorithm used. First, hold up, let me correct it. This results in two false and true positives, that is false positive and true positive, and false and true negatives, that is false negatives and true negatives, due to correct classification or misclarification. Another appropriate metrics that I saw that could work for me was recall, which I already explained above. It quantifies the fraction of the correct number of positive class predictions made out of all the positive examples in the dataset. In the system, if the system mistakes the wrong clause for a right one, then it has a low precision. And if it mistakes a wrong clause for the right one, it has a high precision. And of course, the references that I use, I used Wikipedia, I used StarQuest, Cedar, Hadan, Quantopian, and V7. Thank you very much for listening.